So, Werner von Braun. Interesting guy, a German research scientist who worked for Nazi Germany developing the V program. The V program was a set of wonder weapons, magic bullets that Hitler hoped would win the war for him. There were 4 of them actually. The V1 was a pulse jet, the V2 was the one we think about, it's what we think about as being a normal jet engine, the V3 was a great big cannon, and the V4 was a solid rocket jet, which was so inaccurate, I think only about 24 of them were ever fired at the end of the war. But at the end of the war, Werner von Braun and about 1,600 of his other scientists were rounded up under Operation Paperclip and shipped off to the USA to work on the ballistic missile program. At the launch of NASA, Werner von Braun fell under their remit and is considered to be, I suspect, the father of modern rocketry. He's the one who's most responsible for the creation of the Saturn V rocket. The V2 was the first man-made object that made it into space. Now, it is an awesome and fascinating bit of engineering, particularly in terms of the design of the turbine and the pumps, because the V2 could deliver and burn something like 6,000 litres of fuel a minute. It took 5 minutes to fly from Holland to London. So, pretty impressive thing. It was supersonic. Nobody could hear it coming, and it created a huge psychological terror in the British population. Now, the design of the turbine isn't something that's gone unnoticed. I think Intezga did one where he actually tried to run a skateboard on it. And I thought I would have a go too. And Intezga, though, has changed some of what he does. Instead of giving away the STL files, has them on a site and you have to pay. So I thought I would give it a go, designing my own version of the V2 turbine so I could use it in a generator. And this is how I went about doing it. So I got this. It's actually from NASA. It's their all-singing, all-dancing latest turbine blade, and that is a JPEG. Of course, for us to use it, what we need is an SVG, because we want to import it into a drawing program like Tinkercad. So what I did then was convert that into an SVG using an online converter and imported it into Tinkercad. So when I'd done that, this is what I got. Now, initially, you might be a bit disappointed in that because, of course, what we want is this shape in between, and what we've got is this square, and all of this stuff we kind of have to get rid of to keep that shape. And the question, how do you do that? Well, Tinkercad's got a pretty good tool for that. If we go over to basic shapes and hit the down arrow, scroll down, or you look at the bottom, and what you'll see is something called shape generators. You click on that. It will pull up these different tools, and we want this one, which is called extrusion. If you drag that onto the work plane, then you'll get a pull-down menu telling you what that is. If we position that over there, make that a hole, we can actually see through it to be able to see the shape that we want. Now, on this circle, we've got these points, and we can click on those points and drag them to fill the shape that we want, and you'll see it's flattening it there. On that square is a couple of circles. If we hold that circle, we can twist that round and move these points until we actually create the shape that we want. Now, as you move these points around, so the square points, and twist them using the round points, what you'll eventually get is that, where you've got a tracing of the shape that was in there. So we can get rid of our guide, and we can change it from hollow to solid, and what we have is our turbine blade. So to turn this blade into a turbine of the V2 type, what we need to do is take a disc and just attach a load of the blades to around the disc, and that's where the name of this comes from. They've smashed together blade and disc to create the word Blisk. So this V2 type is known as a Blisk. Now, if you imagine that there's a line joining that point and that point, then those two edges need to be 22 degrees off this straight up and down, or at least what I read said that. But to add these, what we do is highlight the two of them, align it to the center, and align it to that edge. Now it's hidden completely in there. We can unclick that and move the circle away by about 15 centimeters just by pressing the move 15 times, and what you'll get is your blade sticking out of the disc. If we keep on going, of course, it will separate. So if you move back, Once we've got it sunk into the disc, then we can actually do a copy and repeat. Now this will go around the circle here, and we want it to carry that blade with it, so we create another circle, this time 200 by 200, just copy it, 200, 200, and it's 21 high, but we'll change it to say 2. And we'll see that our center disc and the blade are covered by this large outer disc. Then what we do is highlight all three of them, then we copy it and move that by something like 10 degrees. That will give us 36 blades on this, which is pretty much what I want. So we move that by 10 degrees by going to the outer, follow it around 10 degrees, and we'll get 2. And we can continue that by pressing repeat, creating our bladed disc or our blisk. There we go. Now we can get rid of the guide circle just by highlighting the whole thing and sticking it in the bin. Now we want to highlight the whole thing and press merge. Now I want an outer ring on this because I'm fascinated by generation at the edge instead of turning in something in the center. So I want that ring to also carry a set of magnets. And the magnets I'm going to use are 15mm diameter, 3mm deep neodymium magnets. So I've created a ring there at 200 by 200, or rather a cylinder, and I need to put some indentations in the side. So if I take a hole and make that the same size that I want the magnet to be, a little bit bigger so the magnet will fit, so 15.1 by 15.1, and remember they're 3mm deep, so we'll make that 4 so they sit down a little bit. We twist that around 90 degrees, and then we can align those so we get the alignment here and at this time on the edge there, and that will align our hole right there. Now it's at the bottom, so we also want to align to the center of that ring there. So click that ring and align it to the center. When I merge those or group them, then that will create a hole. But of course I want a whole bunch of them, so same routine. Highlight the two that you want. Repeat it, move it by the number of degrees that you want, and in this case it's going to be 10 degrees, and then just repeat that, and it will create the indentations all the way around for me where I can actually glue the magnets. There we go. Now of course I don't really want that to blank off that, I need another hole in there. So if we grab that hole, and this time we're going to make this 180 by 180. Smooth it out. And if we center it in there, and then we can group all of that together. We want a hole in the center of it, and I'm going to put skate bearings in, so I'm going to use a hole of 22mm, so we have to force those bearings in, but it will still lock them nice and tightly together, and then we can group all those three components. So we center them first, and then we can group them. And there is our Blisk ready to print. That's it printed out, and I've stuck a couple of bearings in it, as you can see, and I've also printed a little cradle to hold it, and we have an axle. So let's put it together. Okay, I've got a metal tube here, and what I'm going to do is blow the air on it in one direction, in that direction, and we'll see how it does. That is some crazy speed, eh? They got there with a bit of blowing, as you heard, but it started to hum and it is spinning at some RPM. Now, of course, I've got to stick magnets in this and make a coil for it to make a generator, but the turbine itself, well, it's amazing. Right, I would have said my effort at the Blisk generator went quite well, actually. Now, we'll put these sounds on Thingiverse, of course, should anybody want to use them and should anybody want to beat me to actually making a generator, because I have to add the magnets, I have to make the coil, and then some kind of input. And obviously it's going to work best off pressurized air or possibly steam. But I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.